The following is a presentation from Craig S. Mullins, founder and principal consultant of Mullins Consulting, and George Foucher, founder and CEO of Corelog. Mullins serves as consultant for DataVail and is also the publisher and editor of the database site, a portal with database news, information, tips, and guidance for best practice data management, security, and compliance. Corelog provides enterprise software solutions for data security across both mainframe and distributed platforms. Corelog helps achieve data compliance for PCI DSS, HIPAA, FISMA, Sarbanes-Oxley, IRS Pub 1075, and other compliance mandates. Who Did What to Which Data When was recorded in September of 2016 and features Mullins sharing his experience working with IBM DB2 dating back to version 1 released in 1988. Our presentation today features DB2 Security, and our agenda will cover data protection, data breach issues, compliance and auditing, and a brief overview of Corelog security solutions for IBM DB2.
So, right off the top, if you take a look at the jobs that are done by data professionals, you can kind of break it down into two categories. There's database administration, which you can look at as managing the containers that contain data, and data management, which is managing the content within those containers. Basically, the DBA roles and responsibilities are pretty well known and well supported today. Basically, if you have an enterprise DBMS, there's no argument for management that you need a DBA staff to care and feed that database system. Now, on the other hand, things aren't really as clear-cut when it comes to managing the content of the database, the actual data. With data, the big data and the analytics exploding and multiple DBMSs and all these things that we should be doing on data, protecting it, ensuring its privacy, making sure it's quality, archiving it, extracting it, moving it around, are things that are sometimes done rather haphazardly. Today, we're going to discuss one aspect of one of these areas. That's database auditing, which is an aspect of data protection. So who's involved in this process when we're looking at critical corporate data that needs to be audited? The DBA is going to be involved somewhat, but mostly in terms of setting up the environment and making sure that the auditing solution doesn't impact the performance or execution of production applications. When it comes to database auditing, it's a compliance reason that drives the need. And we'll talk about those compliance issues momentarily. But what this means is that the subject matter experts in the line of business really have to lead. They need to understand the regulations and requirements that dictate the need to audit who accesses what data. Other constituents in the company include the IT security group and your auditors, and they're likely going to be the end users of the database auditing solution. So the primary stakeholders that are involved here are the security team, the business compliance and auditors, and the DBAs. The security group wants real-time access with a secure audit trail and the capability of analyzing the audit data. The line of business and compliance team wants to make sure that there's a separation of duties so that those that are being audited aren't also the ones that are implementing the auditing and have access to modify the audit trail. And the security people are also concerned with simplicity and completeness in terms of being able to produce reports. Then there's the DBA, who just wants to make sure that we can implement this auditing without impacting our database systems. So now that we've put this in place, let's take a look at the current landscape of issues and driving factors that makes having a viable database auditing solution very important. And we'll start with data breaches. Now, unless you've had your head in the sand for more than a decade, you've surely heard the stories of data breaches over the past few years. And there's so many these days that it's almost no longer an interesting story. Let's take a look at some analyst numbers. First, from the 2015 Gemalto Breach Level Index Report. Here we see that last year alone, over 707 million records were breached, and that can be confirmed. The number is much higher than that because more than half of the known data breaches last year impacted an unknown number of records. Now, there were more than 1,600 specific data breach incidents last year, with close to 50 of them involving more than 1 million records. What that boils down to is 22 data records being lost or stolen every second that we can't account for. What about this year? Well, things aren't slowing down any at all. As of July 19th, that was this Tuesday, the Identity Theft Resource Center, another group of analysts, has documented 538 breach events that have exposed over 12 million records. Again, with many of those events exposing an unknown number of records. So there's a lot of data breach going on. If we look at this from a customer perspective, here's a couple data points, again, from Gemalto, and it's showing us that customers expect companies to take responsibility for protecting the data that they share with them. But most companies don't think that that the companies that they do business with are taking that very seriously. There's a breakdown of trust, and that's an issue. What does that issue lead to? Well, if you have a data breach, that's going to erode your company reputation and the loyalty of your customers. Again, from Gemalto, we see that 64% of customers say that they're likely to reduce the amount of business they do with organizations that experience a breach. And of course, if business slows after a breach, that translates into financial losses for the company. But just what type of financial losses are we talking about? Here we're looking at more analyst information, this time from the 2015 Verizon Data Breach Investigative Report. Every year Verizon puts out this report. And what we see here is that the loss for a data breach of 1,000 records varies between $52,000 and $87,000 US, or an average of about $69,500. So the cost per record breached is right around $70 per record. Now, this is the type of data that's been reported for years from various sources, and there's value there. But I think if you look at the chart from Verizon more clearly, it represents the true costs of a breach. There's really no plug-and-play calculation that can determine the cost of a breach based on the number of records breached. So if you say, I breached 972 records, multiply that by $69.50, I get an actual number. No. Instead, you really have to look at ranges that fluctuate as the number of records increases or decrease. So if you look here, you can see for very large breaches, the cost per record is smaller, talking cents instead of dollars. But the total cost is very substantial, so don't be fooled. So really, the greater the number of records, the less the cost per record, but the greater the overall amount of the individual breach is going to cost you. Another group that's looked at this extensively is the Ponemon Institute, and their 2016 report shows that they looked at 12 different countries, 383 organizations, and there's a lot of variation among the country samples, which makes sense. But the consolidated average per capita cost for all countries was $158 per record. And that's higher than what we looked at on the earlier slide from Verizon. Again, you look at what this was last year from Ponemon, it was $154, so the cost is going up. We also see here the total average cost of a data breach per incident. With the exception of Australia and South Africa, all countries experienced an increase in the average total cost over the past year. So we see the cost of breaches is going up. Now, not surprisingly, or at least to those of us who deal with database systems, is that one of the biggest targets for data breach attacks is corporate database systems. It stands to reason that hackers that target your database are going to target the database because that's where the data is, right? Using all kinds of techniques, Trojans and malware and SQL injection attacks, they're going to try to get your corporate data, and it's going to come under attack. These criminals are looking for sensitive information, like financial data, healthcare data, personally identifiable information, or PII. They can use this to steal from you, from the companies they steal the data from, and hopefully to turn a quick buck is their intent. This comes from last year's Verizon Data Breach Investigative Report, and it shows the 3 primary targets of database attacks: point of sale systems, database servers, and then a catch-all that is basically everything else. The orange and the red are the database numbers, and we see how they fluctuate across the years. But they typically represent a very large, if not the largest portion in some years of the overall attacks. If we go back a year to the 2014 report, the database systems were the second most compromised asset, right behind the desktop computer, for internal attacks, that was. So hopefully this series of charts has shown you that we need to do something and deal with it. But if it hasn't, we also see multiple industry and governmental regulations, such as the ones we show here. You can basically delineate between regulations that protect processes and those that protect data. But they both are important for database auditing because databases, of course, contain data. And then there's also processes, the SQL, that's run against the data. So all of these regulations can have an impact on your need to audit data. Now, I'm not going to go over all these regulations. It's each company's duty to know which ones apply to them. And it can be very complex to get your arms around all these compliance requirements. This slide gives a resource of organizations that help to simplify your response to regulations. So if you're digging into the regulations that apply to your organization, I point you to these places where you can get a little bit more detailed information. Now, for the purposes of today, we're going to look at a few of these regulations and how they apply to database auditing. This slide shows things kind of in a database-aware light. Across the top, we have some sample regulations: Sarbanes-Oxley, payment card industry, Gramm-Leach-Bliley, HIPAA, and Basel II. And up and down the first column here, we have the audit requirements mandated by these regulations. Do we need to look at who is accessing the data? Do we need to look at who is modifying the data? Do we need to look at who is making changes to the database system itself? Do we need to look at who is granting and revoking authority to the data? And do we need to look at who is trying to do things that don't have the requisite authorization? If you look across these regulations, you can see that some of them, DDL, DCL, security exceptions, really apply across the board to all of these regulations. When you look at things like PCI, Gramm-Leach-Bliley, HIPAA, they want to know who is accessing sensitive data. That's, who's selecting, looking at any of the data in sensitive tables and that contain personally identifiable information. And then ones like Sarbanes-Oxley and Basel want to know who's modifying that data. So really what you need to do for each regulation that applies to your organization is to build a chart like this based on its requirements and what you need to do for your database systems. Another aspect of this is privileged user auditing. And that privileged user monitoring is really a key requirement to help you overcome the threat of insider access to data. Now, as people who deal with databases every day know that DBAs, some systems programmers, have super user access to database resources and sometimes actual production data. For DB2, this includes your install sysatom, sysatom, DBatom, secatom. Secatom is newer. It was introduced in version 10, and that helps to break down database administration and security administration. So the secatom controls security and leaves the DBAs to control the actual data and database administration activities instead of security. We'll mention secatom again briefly in a couple of slides. Now, it's important to monitor what your privileged users are doing, all these ones I listed, because they're trusted with access to a great deal of sensitive information. And as we all know, yes, you can have external threats to the data, but you can also have internal threats to your data. Now, most privileged users are trustworthy, but as the old saying goes, trust but verify. So what's being done to monitor privileged users? According to the 2016 Cyber Threat Defense Report, from which this little graph comes, not enough. Less than 30% strongly agree that their organization has adequately invested in technology to monitor the activities of these users who have elevated or privileged access rights. So keep that in mind as we go along. And right now we want to dig into the meat of this. What is database auditing? We'll define it, take a look at different ways it can be done, and discuss the pros and cons of each one of these methods. Now, in a nutshell, database auditing means monitoring how stored business data is being accessed. There are many alternative terms that are used out there, including data monitoring, activity monitoring, database auditing, database activity monitoring, or DAM. I'm going to use these terms basically interchangeably, but mostly I'm going to call it database auditing. So what is database auditing? The definition here at the bottom of the slide sums it up. It's the process of monitoring access to and modification of selected database objects and resources within your operational database systems, and retaining a detailed record of that access, where that record can be used to proactively trigger other actions, and where you can retrieve and analyze that data as needed. Okay? With that in mind, moving on. The part here in red is what database auditing encompasses. There are other things like authorization auditing. In other words, looking at who can do what. You're looking at the auth tables in DB2 or looking at the RACF and what's been granted. I'm not really talking about that here. And there's replication auditing, and that's keeping track of the data that's copied, where it's copied to and by whom, and we're not really talking about that either. The topic of this presentation is here in red. It's who did what, and to which data did they do it, and when did they do it. Looking at modifications, your inserts, updates, and deletes, your reads, your selects, looking at the DDL and DCL, as well as the utilities that are processed against your database objects. Don't forget about non-standard access. File snooping, going out to the actual data sets and looking at the data sets without going through DB2. Usually you should protect that through RACF, ACF2, top secret, but some organizations haven't done that, and it's possible that some people may have access to those files. Make sure that doesn't occur. There's the system level zapping with AMASP-ZAP. There's a link here where you can get more information on that. The utility data sets, image copies, unloads, reorgs. There can be data in those data sets that are used by these utilities that you need to make sure you're protecting or removing. something that some of us forget are the database statistics. Some stats tables, like syscall.dist, the column distribution table in DB2, contain actual values. So if someone has access to the syscall.dist table, and you've collected column distribution statistics for the table, say the customer table, and someone has access to the catalog but not the production customer table, they can actually get customer information out of your metadata. So be careful about that. What do we want database auditing to be able to be? We want it to be able to audit access, as we saw in that earlier chart that mapped our regulation to our activities. We need to understand that the auditing solution needs to act as a surveillance mechanism that watches over access to sensitive information. And it brings only the suspicious activity to the auditor's attention. It needs to be selective, because we don't want to audit everything. We just want to audit what the business and regulations require us to audit. It should be comprehensive, meaning that it captures everything we've asked it to audit. It doesn't leave anything out. It should be non-invasive, meaning that the production systems should be protected. We don't want production systems to fail. We don't want them to bog down because we're auditing. And it should be capable of answering the question, who did what to which data when? And that encompasses all of the questions really shown at the bottom of the slide here. So how do we do that? Well, there's 5 primary methods of doing it, and we'll look at each one of these methods on ensuing slides. That's auditing within the DBMS or traces. It's temporal capabilities, which is somewhat new. Auditing from the transaction log, auditing using a network trap, or auditing directly against the DBMS. We'll look at each one of these as well as the pros and cons as we go through the next slides. The DB2 audit trace, native to DB2, comes with DB2, allows you to start audits. It will trace events or categories of events by your auth ID, object ownership, and other methods. Like any other DB2 trace, you can customize how it works, choose the categories of events to audit, the particular auth IDs, and so on. At the bottom of the slide, we see some examples. We're creating a table, and we're saying audit all, and then we're starting a trace, an audit, class 4 and 6, sending it to SMF. Okay. In this case, we need to know what the audit classes are. And this slide kind of boils down what the main audit classes in DB2 are. Details what each class represents, as well as the individual IFKIDs, that you can start the IFKIDs individually if you don't want to start the whole class, or start the class and it starts the IFKIDs automatically when you start the class. So audit class 1 captures failed access attempts. Remember from our chart, that was one of the things we want to capture for certain types of regulations. There are 32 classes altogether. Classes 12 through 29 are reserved for future use. Classes 30 through 32 are available for local use. If we're looking at monitoring privileged user access, then we can look at audit class 11, audit successful access. That'll cut 361 records, which will show us that. If you're really interested in more details on what all these classes mean, you need to go to the Managing Security Manual for DB2 for ZOS. It highlights all of them in the auditing section. Okay, this native audit trace has some issues. One is separation of duties. Privileged users are typically the ones that are assigned the task of starting and stopping traces, and that's an issue. In terms of overhead, that's another issue. Some traces can have a significant impact on other database access. We see here classes 4 and 5 can have a significant impact, up to 20% overhead. Again, depending upon what you're doing. I mean, if you start classes 4 and 5 and are only auditing a table that's not accessed significantly, then it's not going to be 20%. But if it's a significant amount of access on a lot of tables, it can consume a lot of overhead. The other thing, in terms of capturing everything, classes 4 and 5 only capture the first read or change in a unit of work. You can change that behavior by switching to audit policies, which is new in DB210, and that captures all reads or changes, not just the first in a unit of recovery. But audit policies require SecAdam. So you have to change from your SysAdam current implementation and adopt SecAdam. That's a significant impact to DBA operations, and a lot of organizations haven't done that yet. So I'm not really going to go over how you do audit policies, but keep in mind that that option is there. It allows you to have reference things using policies so you don't have to go through a lot of the undue burden of changing DDL, but you do have to change operations. Again, I refer you to the Managing Security Manual for more details on that. So the native DBMS audit, great, comes with DB2, captures a lot of stuff, can be comprehensive, but has issues with separation of duties and overhead. The next method is temporal tables. New to DB210, there's business time and system time temporal tables. What I'm talking about here is system temporal tables. With system time, you can track insertion and modification history of your data. So to do this, you need to do 3 steps. You create the base table with some timestamp columns saying the range during which this data is valid. You create a history table exactly like the base table, and then you enable versioning by hooking the 2 tables together to allow this to happen. Here, we quickly look at how that happens. We'll create a course table with the 3 timestamp columns in it, start and end, saying this is the start when this data became accurate, here's when it stopped becoming accurate, and there's also a transaction start implicitly hidden because it's used by DB2 internally. Next, we define the history table, which is exactly the same as a course table. So we create courses like course. Then we alter the course table and add versioning. What we've just done is now implemented system time temporal data to this table. So we insert 3 rows. We see the data is out here, assuming we're doing this on January 10th, 2012. It's the system start time is when we inserted it. The system end time is, the end of time. So we've got some data in the tables now. How does this help with auditing? Well, now that we update and delete, say we update the price of course number 650 and then we delete course number 600. Now our data looks like this, where the main table has the 2 rows, one with advanced Java where we see the modification happened 5 days later. And we also see in the history table that we've got the old data with the old price and how long it was active. We also see we deleted course number 600. It's now in the history table. So with temporal data, we take care of looking at what's happened. We can retrieve the information directly from the table using regular SQL, but we can also use temporal SQL to do time travel queries and go back in time and see what the data was on for a particular row at a particular point in time using as of in our queries. So this is helpful to some extent, but it's really only useful for modifications. There's no tracking of access to data, in other words, reads or selects, and we don't know who made each change. So some of the important database auditing issues aren't taken care of with temporal data. We also have the potential for a large amount of data to manage, which puts an impact on the DBAs. The transaction log can be used again to capture changes because the database, all changes for the most part, go through the log. So if you've got a way of reading the log, you can take a look at changes made to your database objects, and there are log analyzers that do that. But there's issues here too. Again, it's read only, not going to be captured because the log doesn't capture reads. The log format is a proprietary format. Again, volume can be an issue. You've got to make sure that you can access both your online and your active logs. So that can be an issue too. We're also using logs for two purposes now. That can be an issue. We're using it for recovery and protection. We're using it for audit. It's really meant for recovery and protection. And then there are non-logged operations. Load log no, reord log no, they don't get logged. Non-logged table spaces, lobs typically aren't logged. So a lot of this information gets missed. You additionally can't really do real-time actions on the database log. The fourth method is network sniffing. This technique connects to the network and identifies packets that access the database. And it can work well for distributed client-server database systems, where almost all access is over the network. But those of us who work on the mainframe know that there can be a significant amount of work sent to DB2 that doesn't use a distributed network connection. KICS, IMSTM, TSO, batch connections. They're not going over the IP network. And many legacy applications are written that way. So we'd miss a lot of data if all we were doing was network sniffing using our using our auditing product. Another method is tapping the database server, the DBMS itself, at the control block level. And it's probably the most fail-proof method of database auditing. It can use these connections into the control blocks to trap all accesses, not just network access. And in many cases, it can be deployed without some of the cons of other methods, such as requiring access to transaction logs, starting traces, or requiring DDL changes. But this method interacts very closely with the internals of the DBMS, so you have to take care that the software is properly tested and doesn't impact database operations. One other thing that I haven't mentioned yet that some people try to do and that I want to tell you not to do is to add audit columns to the tables and try to do it yourself. So putting in a last modified date and a last modified user ID column to the table you want to audit. And then saying that every program that modifies the data has to set these columns correctly. That's a really bad idea. Can you make sure that all modifications also update the audit columns? You're trusting all your programmers to do this. You're trusting that any ad hoc modification generally doesn't happen in production, but it can. An ad hoc user would have to understand these date and user ID columns are there and do it correctly. And it also really opens up a can of worms for your privileged users. In this case, the privileged users being the programmers. You know, what if they want to put a hole in there that they can then exploit later? And then what about deleting a row? If you delete a row, you delete the audit trail because you no longer have those modified dates. So generally speaking, just don't do that. So the best approach, they all have merits. You need to examine your needs. Some tools are going to deploy more than one of these methods, depending on the situation. And really, you want to look for feature-laden solutions that can support your auditing needs with minimal impact to your production environment.